Okay, so we're going to learn about intravenous flow rates. Let me spell that right there. Intravenous flow rate calculations. And it's actually really pretty easy. The key to this calculation is understanding dimensional analysis and paying really close attention to your units. So let's take a look in a little overview about what a flow rate is. First of all, prescribers will order IV fluids or infusions, IV infusions. And the medication order will usually include the fluid type, which is your base solution, for example, like normal saline, sterile water, dextrose 5% water, something like that. And then any additive that must be added, such as electrolytes or medication. So an example of that would be, let me show you something that would show you what a medication order might look like. Here is a medication order. It gives you the drug, it gives you the fluid volume, its base solution, which is dextrose 5% water, the fluid volume, and how fast to administer it. So this would be an example of what we typically see for a medication order when we're looking at flow rates. So the nurse is responsible for monitoring the infusion and to make sure that the IV pump that they're using has the proper flow rate on it. But a lot of times the pharmacy or the pharmacy technician will be required to have to calculate some stuff because they may need to know, well, how long is it going to take to infuse? When are they going to need the next IV bag? How many are they going to need for the next 24 hours or 48 hours or 72 hours? So there's a lot of things that will come into play, and knowing how to calculate flow rate is necessary when you're an institutional pharmacy. So let's take a look at what calculating a flow rate is. And when you set up the problem for a flow rate, always start with volume over time provided in your problem set. Volume is measured by milliliters, liters, time, hours, minutes. So look at your units and make sure you start with volume over time. And then using dimensional analysis, move to the units that the question is asking. Now, sometimes you don't need to move at all. Sometimes when you put your volume over time, the question is asking milliliters per hour, and that's what you're given. So you don't need to do any crossing off or dividing or multiplying. You just calculate the volume over time. So that's the formula for flow rate. But when I do flow rate, I really don't look at a formula. I just start with my volume over time, and I move to the units that the question's asking me. And that will usually give me my flow rate. So let's take a look at a problem here. A physician has ordered a 1 liter bag of IV fluid to be infused over 10 hours. What is the IV flow rate in milliliters per hour? So it's looking for milliliters per hour, okay? So first off, we have 1 liter per hour. So I'm going to first convert my liters to milliliters. We know there's 1,000 milliliters in 1 liter. So I'm going to just change that to milliliters and get rid of liters, so I'm working in the same area that I need. You could start with liters over hours and then write it as dimensional analysis, something like, let me add in. So you could start with 1 liter times, and then go to your dimensional analysis. There is 1 liter in 1,000 milliliters. And then we want to put our time in there, and we are looking at 10 hours. Okay, so then you're going to get what we got here, which is milliliters per hour, because these are going to cross off here. And then you're going to have milliliters per hour. And if you divide that, your correct answer is right here. There's 100 milliliters per hour. Now, I just switch it from liters to milliliters because there's no reason to go through all of this. You could just write it just like this and you're good to go. Okay, so that's the first problem. Let's take a look at another one. Oh, let me close that out first. There we go. Okay, a 1 liter bag of IV fluid is administered at a flow rate of 120 milliliters per hour. How long will it last? So it's asking me for time. It's asking me how long will this bag last? So flow rates can be rearranged to solve different parameters. Recognizing this concept is helpful when you're solving problems and calculating flow rate. So the question's asking time. So our final answer is going to be how many hours is it going to last, okay? It doesn't say minutes, so we're going to stick with hours. So start with your volume over time, but since you're doing figuring out time, let's flip this, let's invert this and go time over volume. So we have 1 hour and 125 milliliters, and we're infusing how much? We are infusing 1,000 milliliters. So we're going to cross off these units here because we got rid of milliliters, and all we're left is hours, and that's what we're looking for right here, right? How long will it last? So 1,000 divided by 125 ends up being 8 hours. And that's your answer for that question. So it's going to last 8 hours. So a lot of times when we're looking at flow rates also, this is often what the pharmacy tech needs to do. They need to know the number of bags to make. Like, how many bags am I going to prepare for the next 24 hours? Because I have an 8-hour shift. I'm going to be there for the next 8 hours, but this patient's going to be here for 24 hours, and they can't run out of IV fluid for the next 24 hours. So I got to make enough IV bags to send up to the floor to the nursing unit so that they can make sure that they have a constant infusion going on for the next 24 hours. Okay, does that make sense? So a lot of times that's what a pharmacy technician does, but they don't really tell you that in your formula or your medication order. You have to figure that out on your own. So here in this, in the previous problem, the IV bag lasted 8 hours. Okay, so if the pharmacy technician must make enough IV bags to last the next 24 hours, how many will they make? Well, the number of IV bags will equal 24 hours over the length of time the bag will last. You're just going to divide it. We know 8 goes into 24. There's every 8 hours, 3 times a day. It's 3. So your correct answer here is 3. Okay, so we need to prepare 3 bags, send them to the nursing floor, and they'll have enough to prepare that patient for the next 24 hours until I come back the next day. Another problem you can see in calculating flow rates is this type of problem. Let's take a look at this. A prescriber has ordered a 1-liter bag of D5 normal saline, dextrose 5% dextrose in normal saline, to run at 150 milliliters per hour. How many bags will need to be prepared in a 24-hour period? Okay, so we're doing the exact same thing. Must determine how long one bag will last. That's the first thing we have to figure out. And to figure that out, we have to start with our time. We have to figure out time, right? So we want to figure out hours. So you notice here, I want to figure out the hours. So I have 1 hour over 150 milliliters times 1,000. I'm going to cross this off, and then I'm just going to divide this, and this is my answer right here. Okay, so it's going to last 6 hours, not quite 7 hours, just a little bit less, a little over 6.5 hours. So now we're going to take our 24 hours divided by our time, and we get 3.6 bags. My question to you, can you send 0.6 of a bag to the floor? Like, are you going to send them part of a bag, or no? No, you're not. You're going to prepare them an extra bag so that it will last for the full 24 hours. So you always want to round up when you're calculating the number of bags to prepare, because if you only prepare 3 bags, let's say you rounded down and you prepared 3 bags, they would run out in 22 hours instead of 24. And then what are they going to do for the next few hours? So you always want to round up. Even if this was 3.2, you would want to round up to 4 bags. So our correct answer is to prepare 4 bags right here. Okay? And that is how you calculate a problem like that. So the last thing I want to talk about is expressing flow rates in different units. Usually it's expressed in volume over time, but flow rates can be expressed in other terms depending on the medication. Example, what if we're calculating heparin? Heparin's measured in units, so it might be units over time. If you're calculating potassium, you're going to be doing milliequivalents, so milliequivalents over time. So prescribers can write an order by stating the dose to be infused in a period of time. A dose is typically measured in milligrams, units, milliequivalent, something like that. So sometimes you're going to have to figure that out instead of volume. You're going to have to figure out dose. So the thing is, and I said this before, if you're using dimensional analysis right here, if you're using dimensional analysis, it makes the adjustments easier. Just make sure you pay close attention to the units and what needs to be eliminated and what the final units are asking for. So if you do your dimensional analysis, you shouldn't have to memorize any other formulas. There's no formula requirement. So let's take a look at a problem such as this. A physician has ordered 250 milliliters of an IV piggyback, and in that they want 150 milligrams of hydrocortisone to be infused over 4 hours. How many milligrams of medication should be administered per hour? Okay, so it's asking how many milligrams per hour. Okay, so that's what we want to get to. So the question is asking milligrams per hour. Find what is in your word problem that is in milligrams. So if we read in here, where is milligrams? We have right here 500 milligrams. So we want to start with that. And then what do we have in our problem that's in hours? Okay, we have 4. So if we put 500 milligrams over 4 hours, are we at our solution? Because we're kind of go to milligrams per hour. Yes, we are. So we're already at milligrams per hour. We don't need to do any dimensional analysis. We just have to, 4 divided goes into 500, and here's your answer. It's pretty simple, okay? One more problem that I wanted to do, and then we're done. So a patient receives, no, I have 2 more problems. Sorry about that. A patient receives 8,100 units of heparin over 6 hours at a constant rate. How many units of heparin does a patient receive each hour? So what are we looking for? We are looking for units per hour. And what do we have that's units? We have 8,100 units. And what do we have in hours? We have 6 hours. See, 8,100 units here, and we have 6 hours. So if units over hours, that's what we have, units over hours. 6 goes into 8,100, 1,350, and there's your answer. Okay, the last problem I wanted to show you is this one. The following medication order is received by the pharmacy. So we have cefazolin, 1 gram. 1 gram is equivalent to how many milligrams? That's my first question I'm going to ask you, because we're going to have to convert that. So 1,000 milligrams is equivalent to 1 gram. So we're going to work with 1,000 milligrams. Our fluid volume is a D5W base, 150 milliliters, and then we're going to administer it over 120 minutes, okay? So what volume of fluid is administered per hour? Okay, let's take a look at that. I'm going to try and write this out. So let's start with our volume over time. So we have 150 milliliters over 120 minutes. Okay, and we are trying to get in a volume of fluid over hours. So our final answer needs to be in hours. So milliliters over hours. That's what we want to get to. So we're in milliliters per minute, so we have to convert our minutes to hours. So minutes on the top, because we want to get rid of that, right? We want to be able to cross that off, and hours on the bottom. Okay, now how many minutes per hour? How many minutes are in an hour? There's 60 minutes in 1 hour. So we can cross off our minutes, and then you're going to just calculate it. 150 times 6 divided by 120. The answer is 75. And that's your answer to that part right there. So now the next one is asking how many milliliters of medication are to be infused per hour. Well, it's asking milligrams of medication. So our answer needs to be in milligrams per hour. That's what our answer needs to be. Okay, and we have, if we look at what we start with, what is our weight? We have 1,000 milliliters, or milligrams, I'm sorry, 1,000 milligrams. And we're infusing it how fast? In 120 minutes. So we're going to multiply that. We're going to set up our dimensional analysis. We're going to do minutes over hours. And again, there's 60 minutes in 1 hour, so we can cross those off. And then you're going to calculate that. 1,000 times 60 divided by 120 ends up being 500. And that's our answer, is 500 milligrams per hour, and that's how you figure that out. Okay, so that's all I have. Here is the reference of the book that I used. If you guys are looking for more information, you probably could find this in the library. And that's all I have. Have a great day.